Hello, chemistry. Okay, so already I see I might have made a mistake on number 3. So here's the list of people that texted me. I think you might be right on number 3. It doesn't look exactly right because of that squared. I wonder if I just plugged in the number wrong. So I'm gonna sorry, a little wind in my hair there. So I'm gonna go right away. So 379 are the ones that we're gonna do. So the first one we're gonna start off with is 3. So 3 was, what is the molar solubility of Ag and S2 minus and Ag and S2 minus of Ag2S when added to 0.1 molar. So this looks like I may have messed up the number here. So all right, so we got Ag2S gives 2Ag plus S2 minus. And right off the bat, they tell me there's a molarity of 0.1 molar K2S, which means that 0.1 molar is my initial S2 minus. So then minus X plus X, plus 2X plus X, 0.10 plus X, 2X, and then it's going to be KSP, which is 1.6 times 10 to the negative 49th equals 2x squared times 0.100 plus x. I'm guessing that wait a minute. Calculators. I gotta get my calculator. Okay. Alrighty. So we got F2 solve 2x squared. And I think I messed that up. Plus x equals 1.6 times, times 10 to the negative 49th, comma x. Yeah, you guys are right. So, all right, so I'm getting x to be 6.3 times 10 to the negative 25th, and okay, so then it's asking for my molar solubility, which is this. Then Ag plus is equal to that number. What is it? 6.32456 times 10 to the negative 25th times 2. And that gets me 1.26 times 10 to the negative 24th. And then S2 minus is 0.1. So for those of you who were questioning that answer, you are right. I think I probably just forgot to put that 2 in there on the calculator. So there's your answer. So good job on picking that up. I better, no. All right. I'm going to actually have to come back to this and write those numbers down. Okay. All right. Next question was number 7. I think 7 was like the ridiculous one. So let me just sneak over to that one. Wrong page. Okay. So 7 says 30 milliliters of 0.01 ZnI2 is added to 50 milliliters of 0.01 KOH. Okay, so I'm going to skip over the Q versus K. Let's just assume that a precipitate occurs. So we're skipping 1 because obviously the Q is greater than the K. So Q greater than K. So now now we have to do our step 2 is going to be that little that thing we did way in the beginning of the year when we did concentrations of ions. So we're adding ZnI2 plus KOH gives me ZnOH2 plus Ki balance. And now what we're going to do is we're going to do our limiting reactant. So our original moles of ZnI2 is 3 times 10 to the negative 4th. That's just molarity equals moles over liters. And then our KOH is 5 times 10 to the negative 4th. Okay, so now these are both our starting off moles. So first thing we have to do is find our limiting reactant. Second thing we have to do is find out which one's excess. So using a little stoichiometry, you can figure out that this one is our limiting reactant because if you go from here to here, it's going to divide by 2. And if you go from there to there, it's just 3 times 10 to the negative 4th. So this one's my LR. This one's my excess. And now what you're going to do is you're going to take your limiting reactant and convert to moles of this one. So you're going to go 5 times 10 to the negative 4th moles of KOH. And then we're going to convert from 2 moles KOH to 1 mole ZnI2, giving us 2.5 times 10 to the negative 4th moles ZnI2. And then we're going to take our original moles of ZnI2, 3.0 times 10 to the negative 4th original minus 2.5 times 10 to the negative 4th reacted to give us our leftovers 0.5 times 10 to the negative 4th unreacted. Okay, so there's our original. That's our, now when we do our KSP part, now we can find, we're going to have some unreacted ZnI2, really just the Zn plus 2. That's kind of what we're looking for. So then what you're going to do is you are going to take your solid here, and we're going to KSP it. We're going to throw it into solution and work backwards. So, I'm going to do that now, and we're going to say ZnOH2, so this is step 3, gives me Zn plus 2 plus 2OH minus. And now our original Zn is going to be 0.5 times 10 to the negative 4th moles over our total volume. Our total volume is 50 and 30, so 0.080 liters of solution, 0. And now it's basically just a common ion question. So blah, 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 minus x plus 2x, 2x, 0.5 times 10 to the negative 4th divided by 0.08 gives us 6.25 times 10 to the negative 4th plus x. So those are our equilibriums. And now what we would do is we would plug these in with our KSP given is 4.5 times 10 to the negative 17th equals 6.25 times 10 to the negative 4th plus x times 2x squared. And now we TI-89 this thing. F2 solve 6.25 times 10 to the negative 4th plus x, close parentheses, times 2x squared equals 4.5 times 10 to the negative 17th, comma, x. Oh, parentheses. And let's make sure I got the right answer here. There's like 3 choices, but 1.34 times 10 to the negative 7th. Is that what I got? Yeah. So I got x equals 1.34 times 10 to the negative 7th. So now, what is it asking for? Well, okay, so there's my molar solubility. My concentration of Zn plus 2 is going to be basically this 6.25 times 10 to the negative 4th, and then 2 times that number was 2.68 times 10 to the negative. I guess with sig figs it should have been 2 sig figs, so 2.7. So this should be 6.3. And the OH minus is 2.7 times 10 to the negative 7th. Right. Okay. So there's your answer for number 7. Okay, I made it a lot faster because I just didn't do that step 1. So, good. You can pretty much count. This is going to be like the hardest question probably on the test. So make sure you do this one. Practice this one. All right, and then 9 was okay, hold on. Okay. Sorry. Let me just go back here. Okay. What is the sign of Gibbs free energy in the following scenarios? So, all right, so really, I mean, you could go through the delta H and the delta S and see if it, you'd get a negative delta G, but just use common sense. Water freezing at negative 15 degrees Celsius, that's below the freezing point, so that is going to happen. If you put water if you put water and you put it in a freezer that's at negative 15, that water will freeze. That is a spontaneous thing that'll happen. Therefore, delta G is negative because it's spontaneous. Like, it just it's going to happen. It's going to go all the way to the end. Like that you're not going to have really any liquid left over. It's going to be frozen. Okay, octane combusting with oxygen to form carbon dioxide and water at 1 atm. This one, I would just use common sense. I mean, the delta H's of combustions are so negative that no matter what, if you had like a little bit of entropy lost, I mean, whatever, it doesn't really matter. So that is definitely going to be spontaneous. If you put a match there and you give it activation energy, that thing's going to go. So, so that is also negative. Most combustions are going to be spontaneous. Okay, C says water decomposing. So I don't know about you, but I have not seen too much water all of a sudden change over into hydrogen and oxygen. I've seen water boil or evaporate, but if water started turning into H2 and O2, we should really look out because hydrogen is incredibly, incredibly explosive. So being that generally doesn't happen, you could then say delta G is positive. That is non-spontaneous. Though in the other direction, it's a combustion, and therefore it is spontaneous. So you could think of it that way as well. And then D says water freezing at 25 degrees Celsius. Once again, not going to really happen there. It would do the exact opposite. If you had solid water, it would turn into a liquid at 25 degrees Celsius. That's like 70 degrees Fahrenheit. So I don't think water is going to be doing too much freezing at that temperature. So that is also a positive, not spontaneous. Okay, so if you still have questions, I will try to answer them to the best of my ability. I will give you guys your test at around 8 in the morning, and then you'll have till midnight. So keep working away. You guys are asking good questions. Thanks for catching that one problem. I gotta go back and see what the answer was because I got the answer wrong, so I gotta redo that one. But thanks again, and good luck tomorrow. All right, bye.